Since 2007, 3V Geomatics has been dedicated to developing world-leading InSAR technology and has grown our portfolio in over 40 countries around the world. Our staff of over 50 employees helps companies by using our cutting-edge algorithms to push the boundaries of early warning monitoring systems within all sectors, including mining, civil infrastructure, pipeline networks, and oil and gas fields. Clients access our products using a large variety of custom-built plugins, web-based applications, and our web-based Motionary portal. We keep people, property, and places safe with near real-time products that are tailor-made to fit the specific needs of each client. Our dedication to safety is matched by our commitment to provide the best hazard detection possible as early as possible. By using commercially available satellites like ALOS-2 and pairing the data collected with 3VG's advanced phase detection algorithms, we are able to report on new risks, displacement velocity, risk acceleration, statistical hazard identification, and multi-orbit monitoring. Interferometric synthetic aperture radar, or InSAR, can detect tiny movements of the ground over time. The satellite bounces radar energy off the Earth's surface, forming an image of the ground. Each image covers thousands of square kilometers. By taking the difference between multiple images, we begin to detect surface movement. The more images, the clearer the picture of what's happening. Special satellites are used to penetrate vegetation and map displacement with centimeter precision. Millions of points are generated, representing the rate of displacement at that location. Each point can be clicked to see a graph of the displacement history. Machine-generated polygons highlight displacement hotspots for easy identification and alerting. An inventory of displacement hotspots is produced over the entire area. Pipelines and other assets are overlaid on the displacement data to determine risk based on proximity, slope, and other factors. Accelerations indicating progressive displacement are highlighted to provide actionable risk mitigation in near real time. InSAR is ideal for monitoring large areas with centimeter to millimeter scale accuracy. Entire pipeline networks can be covered no matter how remote or difficult to access. ALOS-2 data is important to 3VG because no other wavelength is capable of penetrating vegetation. X-band and C-band data does not produce enough coverage. With the increase in coverage, we are able to quantify the magnitude and extent of geohazards. In 2014, 3VG pioneered the Rapid Report. This product provides displacement information in near real time. ALOS-2 Rapid Reports are delivered during peak ground displacement seasons, soon after image acquisition. Displacement is indicated using a colored heat map, raster with confirmed displacement areas outlined in white. Results also include the size of each displacement area and distance to critical infrastructure. Comprehensive reports complement rapid reports by providing the history of ground displacement over time. tens of millions of data points are produced for each product delivery. Each point corresponds to a pixel measured in successive ALOS-2 images over the same footprint. The graph shown here shows the displacement over time for a select group of points. ALOS-2 is more suitable than other sensors over dynamic terrain such as permafrost areas. 3VG has innovated permafrost maps for the Canadian Arctic. The displacement chart on the right shows an example of thawing from June to August, followed by a time of stability once the ice has fully melted. These maps are used by engineers to avoid building on permafrost areas and to assess damage to their assets after the spring thaw. Operators use 3VG's L-band monitoring products alongside ground displacement to understand the ground dynamics near their assets. The white markers show the locations of strain gauges installed by an operator. This equipment was installed after a 3VG report showed where displacement was occurring. InSAR is able to detect previously unknown displacement for further investigation. Ongoing monitoring of water reservoirs is possible with ALOS-2 3-meter data. The high-resolution images generate hundreds or thousands of points over this infrastructure. The added benefit of penetrating vegetation also allows us to monitor surrounding slopes upstream from the dam. The Itwango Dam is a 237-meter hydroelectric dam under construction in northwestern Colombia. In May 2018, 2 separate landslides occurred on the right abutment of Itwango Dam. The landslides blocked the river diversion tunnels 6 months ahead of the planned reservoir fill date. 23,000 people were evacuated downstream of the dam. In total, more than 100,000 people were affected by these events. 3VG has been acquiring ALOS-2 StripMap 1 images every 14 days over the Itwango Dam since July 2018 for ongoing monitoring. An ALOS-2 InSAR rapid report first identified new displacement 5 days before one of the landslides, and the first InSAR comprehensive report identified 39 displacement areas. 7.4 million data points were generated around the reservoir, along with time series charts for every data point. Google Earth KMZ files are used to visualize this product and are accompanied by a GIS database for further analysis. A displacement area detected for this client is shown here. In addition to the magnitude of displacement, the ascending and descending images can be used to provide the direction of movement. The results show that the slide is moving downwards and to the west. Other slopes above the dam continue to show significant instabilities and are being continuously monitored with the help of ALOS-2 imagery. The second case study focuses on a remote mine built into steep mountains in Asia. It is only accessible by a mountain road traveling through dense jungle. The topography is rugged, climbing from sea level to more than 4 kilometers over an 80-kilometer-long road. The road is the main supply line to the mine and to the village where the workers reside, and acts as the main route for electric utilities. Any geohazards along the road can disrupt the supply chains that support the workers, as well as the mining operations. This is one of the rainiest places on Earth, receiving 12 meters of rain per year. The wet conditions and steep topography contribute to widespread slope displacement issues. 3VG initially tested monitoring over the mine with dual-look X-band data, but coverage was limited due to vegetation and many geohazards were missed. Once reliable access to ALOS-2 data became possible, we started using it for monitoring. The difference ALOS-2 has made to this project is profound. Over 11,000 people live in the mining town and nearby settlements. The number of confirmed geohazards has increased dramatically, providing an early warning to the residents and the mine operator. Circled in white are numerous geohazards on the slopes surrounding the town. Without access to regular ALOS-2 InSAR reports, they would be vulnerable to these risks developing overhead. Regular scanning of this area with ALOS-2 allows 3VG to issue alerts as soon as new displacement or accelerations occur. In many cases, InSAR is the only tool that can highlight new displacement in this area. Our third case study focuses on pipeline right-of-ways, which often traverse thousands of kilometers across hilly, vegetated terrain. 3VG is currently using ALOS-2 imagery to monitor more than 30,000 kilometers of pipeline in the United States. Most geohazards that affect pipelines occur in vegetated areas. Because of this, L-band is the only option for mapping geohazards around a pipeline. Many of these areas we monitor are in the Appalachian Mountains, which are susceptible to landslides. This region of the United States is known for having frequent landslides. Nearly complete monitoring coverage is provided around the pipeline, identified here as a blue line. Geohazards around the pipeline, such as the red displacement hotspots, can be accurately mapped. Note that the green areas, indicating little to no displacement, are also valuable knowledge for the pipeline operators. Here, we see two events that occurred before 3VG started monitoring this pipeline. The top photograph shows a pipeline explosion that occurred in 2012, while the bottom photograph shows a landslide that affected an airport runway in 2015. 3VG uses multiple ALOS-2 footprints along the pipeline right-of-way to generate an inventory of ground displacement. Hundreds of ground displacement areas may be present around a pipeline. The operator can use the size and severity of the displacement, along with its distance from the pipeline and the total slope to prioritize inspection and maintenance. Dual-look ALOS-2 image footprints can be used to derive displacement in the up-down and east-west directions. Here, we see displacement results from ALOS-2 ascending and descending footprints. Each footprint measures displacement along its line of sight, capturing only the component of displacement that is aligned with the look direction. Combining these two footprints indicates the total displacement that is occurring, as shown on the right. With the ALOS family of satellites becoming mission-critical for many projects, infrastructure operators want more data. 3VG is continually increasing the scale of InSAR monitoring and deploying early warning systems worldwide. Higher volume and reliability of ALOS-2 and ALOS-4 data are needed going forward. High-resolution data are crucial to identify local displacement that causes damage to infrastructure. In 2018, 3VG used ALOS-2 10-meter resolution data to monitor the area shown on the top. The resolution proved insufficient to identify a known geohazard. In 2019, we switched to 3-meter data, shown at the bottom, which significantly improved the point density and successfully mapped the geohazard and its displacement profile. The number of images acquired during the year are also a key consideration. Frequent imaging is necessary to provide early warning. This is a displacement map derived using 8 ALOS-2 images acquired over a year. The displacement rate has gaps, and the time chart only shows a generic downward trend. The figure on the right shows improvements resulting from increasing to 16 images per year. The displacement rate has nearly full coverage, and no gaps are present, even in the big red hotspot. Furthermore, the displacement profile shows 2 significant accelerations that occurred during the year. Operators can only be alerted in time if the images are acquired frequently. In order to continue the work that has begun on early warning detection monitoring, 3VG needs hundreds of ALOS-2 footprints globally. Existing footprints need to be continued, and new ones need to be tasked. About 20 high-resolution images per year are needed for each footprint. In addition to higher imaging capacity, the ability to task images online and download them from the cloud would streamline operations. ALOS-2 has already made a large impact on early warning detection monitoring, but it does not stop there. With the upcoming launch of ALOS-4, there is potential to increase the impact that risk monitoring provides for operations, safety, and environmental protection around the world.